So today, we are going to learn how to do proofs with congruent triangles. This is actually my favorite part of geometry, is like the next couple of days. You may not agree with that, but this is my favorite part. So what's gonna happen is today we're gonna learn two shortcut ways to show that triangles are congruent. And then we use those shortcut ways to show that triangles are congruent in a proof. And I gave you guys a cheat sheet that has the common steps for these proofs. So if I were you, I'd always,
We can put on those.
oh, okay. I would have these out every day because for the next, several days, we're gonna be doing these proofs. So if I were you, I would just have this out. Now, yesterday, we talked about showing two triangles are congruent. And you remember if we were writing it down, we had to write down all three sets of angles were congruent and all three sets of sides were congruent to show that two triangles are congruent. Well, there are four shortcut ways that we're gonna do, and those four shortcut ways help us be able to do show congruent triangles easier. So the first one is called side, 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 and we use SSS to abbreviate it, okay? And what that says is in one triangle, if the three sides of one triangle are congruent to the three sides of a second triangle, that means those two triangles are congruent. Automatically, the angles will be congruent if your sides are congruent. It does not work the other way though. If your angles are congruent, that doesn't mean your sides are congruent. So, this first question, you're not gonna love, but there's not much. I think there's one in your homework today. But what we have to do here is they're giving us three coordinate points for triangle ABC, and then the three vertices for triangle EFG, and we have to find the distance between them. Now you could graph them, but honestly, the way it is on your worksheet today, they're not graphed. So here's what I'm going to tell you. When you're doing these problems, okay, you have triangle ABC and you have triangle EFG. And what we have to do is we have to find the distance between A and B. So I'm going to write that here. This is the distance between A and B, okay? Then we have to find the distance between B and C. And we want to find the distance between A and C, okay? Once we get those, then we can start finding it on this triangle, and we don't know yet what side angle AB should be congruent to here. But when you go and try to find EF, okay, so if we're finding the distance of EF, if this does not match one of these three distances, you can stop right there and say they're not congruent. But if this one matches these, then you have to keep going, and then you would find the distance from F to G, and you would find the distance from E to G. Okay, so here's what I'm gonna do. I'm gonna find the first one, and then you guys can, I'm gonna split you up and you can figure out the distance for the rest of them. So the first one that we have to find, kids always ask me like, how do I know which ones to find? Between A, B, and C, you're gonna find the distance between A and B. you're gonna find the distance between B and C, and you're gonna find the distance between A and C. So if you get that without drawing it out, you can do that. Then when you do EFG, you wanna find the distance between E and F, E and G, and F and G, okay? So I'm gonna start with the distance between A and B, and they tell us that A is 1, 1, and B is 0, 3, okay? The distance formula is right here, and when you do these, think of this as x1, y1, and x2, y2. And what we're gonna do is we're gonna go ahead and find the distance between A and B. Now, if you follow the formula, what you have to do is subtract your x's first, and you can go x2 minus x1. So we're gonna go 0 minus 1 squared. So x2 minus x1 is 0 minus 1 squared plus, and then for y2, we'd subtract this way also. We'd go y2 minus y1, which is 3 minus 1 squared, okay? Then 0 minus 1 is a negative 1 squared, and 3 minus 1 is 2 squared. And this is where kids get this wrong, so please pay attention to this. Do you guys know in math, if you square a negative, what do you get? A positive. So when you square negative 1, it's going to be 1, a positive 1. If you go to put that in your calculator, you can. If you wanted to type what's under the square root in your calculator, you can, but you would have to use parentheses to do that, okay? Then 2 squared is 4, so this is going to be the square root of 5, okay? Now, what I want to do is let's have the first row do BC, okay? And then let's do Caleb's row do AC, Miski's row do EF, and then Suhela's row do FG, and then, I probably split you guys up too much. The rest of you can all do EG, okay? So we're gonna, oh, and one thing I should have said to you guys, you can stop when you get the square root of something. You don't have to take the square root on your calculator, okay? Is that music from Mr. Chad? If somebody in their row gets an answer, do you wanna let me know? Suhaila, what did you do?
For FG, we got the square root of 5.
Okay. And that is good because that matches what we got, right? Okay. Anyone else have an answer for, which one did you do, Matt? EF? Yeah. EF, square root of 17? And that is correct. Anyone else get an answer? How about the first row? Did you guys get BC yet? Anyone? What did you get? Square root of 8? Okay, that sounds right. Second row, did anyone get AC? What did you get? Okay, and that looks right, correct? Because now we have 2 square root of 17s and 2 square root of 5s. So what we would hope is that this one is the square root of 8, but I don't think it is it?
I think it's like 0 or something. Square, the last one?
Square root of 18, yes.
0.
I wonder if you didn't use parentheses around a negative. So like if you're squaring a negative, it's positive. So that's probably what you did wrong. So this one's square root of 18. Now, in your homework today, I think there's one you have to do like this. Don't be surprised if like 4 of them are equal, because that will happen sometimes. As long as this is equal to 1 in the other triangle, you're good. As long as this is equal to 1, yep.
Do we have to like show our work on every single one for the homework today? Like, so we have, what we did on A, B, what we have to do on every single one?
I hope it's gonna take a whole piece of paper.
Well, show some work.
Well, you can do it all on your calculator.
Not really.
Yeah, you kinda can, it's kinda like mental math.
I'd like to see some work, okay?
What if we write it out, but we don't like?
What's that? Okay, so do you guys get for this one, it's no?
Yeah.
Everybody? And it's only because one of them is square root of 8, and that one doesn't have a match down here. But I think in your assignment, like maybe 2 of them up here are the same, and then 2 of them down here are the same. So I think it turns out we're all 4. There's 4 of them that are equal, and that's okay. All right? Now we're on to the proofs. So, these proofs, I have kids that catch on super, super fast, and then I have some kids that struggle with how do I know which steps to use. I cannot tell you enough, this is a ton of points on our quiz and our next quiz. So you have to pay attention, and please ask questions when there's something you don't understand. So first of all, we're given 2 things. So I'm gonna go here and I'm gonna write down QU is congruent to AD. And I'm gonna put them both under step 1. And all of you know that step 1 is given. Now I did type your problems up today. I haven't done that in the past. But if you were doing this in the book, you'd have to write down given, prove, statements, reasons, but I'll try to print or copy worksheets if I can. Now, when you do this, and I say this every year, and I have kids not do this on the test, and typically these are the kids that really struggle. So everything that's given and everything you write down here has to be listed in the diagram or marked in the diagram. So QU is congruent to AD, that's marked. QD is congruent to AU, that's marked, okay? Now yesterday I talked about a step where if 2 triangles share a side, what is that called? What was that? Reflexive property. So, guys, that's enough, okay?
Well, what is that?
So, DU, what's that?
I can hear music.
It's Mr. Chex, I think.
It's definitely Ryan Kilmer.
DU is congruent to DU, and that is reflexive property. We use reflexive property in almost every, or I shouldn't say almost every, but a lot of proofs in this chapter. Anytime 2 triangles share a side, that is reflexive property. Now, according to side, 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 if you ever have marks on one triangle where all 3 sides are congruent to 3 sides of the other triangle, that is enough to say that your triangles are congruent. So you come down to your last step, okay? And in these, you can bring this down, okay? And you would say the 2 triangles are congruent. QUD is congruent to triangle ADU. And that is by side, side, side. Do you guys understand that?
Yeah.
Everybody good with that? Now, one thing I will tell you guys before I forget, when you're marking sides or angles on a diagram, the first set of sides that are congruent, you use 1 dash. The second set, you use 2 dashes. And the third set of sides that are congruent, you use 3 dashes. Just like with angles, you'd start out with 1 arc, 2 arcs, and then 3 arcs, okay? But that's all we have to do for that one. So now, these are in your cheat sheet, and these are steps that you have to do in proofs. So the first one is reflexive property. This side is shared by those 2 triangles. So anytime you have that, you can say that those 2 sides are congruent by reflexive property, okay? There's also a midpoint theorem, and that is anytime you see that you're given that something is the midpoint, what you're gonna do is mark that on the diagram. So if N is the midpoint of MO, that means these 2 sides are congruent, and what we write down is midpoint theorem. You only use midpoint theorem when you're given a midpoint. Then vertical angles. Do you guys recognize angle 1 and 2 as vertical? Whenever you have vertical angles, you'd mark them, and then you would say angle 1 is congruent to angle 2 by vertical angles theorem, okay? And then we have a segment bisector. So anytime you see that a segment bisects another segment, that tells you you're going to use definition of segment bisector. And you have to look at which one bisects the other one. And this says PS bisects QT. So that means PS cuts this in half, and these 2 pieces are congruent. So you would say that, and it's definition of segment bisector, okay? Then definition of angle bisector. If we have that segment bisects an angle, anytime something bisects something, it cuts it in half. So if CA bisects this angle, that means those 2 parts of the angle are equal. You say those are equal by definition of angle bisector, okay? And then the last thing is alternate interior angles theorem. If these 2 are parallel, what happens is this angle is going to be congruent to that angle. Do you understand that? If these are parallel, those 2 angles are going to be congruent, okay? So let's go and try another one of these, and this we are going to do by ourselves. So let's copy this down. We have GH is congruent to KJ, and we have another thing, HL, and I always do one on top of the other. I don't list them all in a row. HL is congruent to JL, and L is the midpoint of GK, and those are given. So now what we're going to do is mark that on our diagram. So we have GH is congruent to KJ. We have HL right here is congruent to JL. And notice I used a different amount of dashes each time. Now if you notice, we're given a midpoint, okay? So when we're given a midpoint, that means you have to use midpoint theorem. They're telling us L is the midpoint of GK. What that tells us is this piece is going to be congruent to that piece. So we're using this right here. If they tell you you have a midpoint, you use midpoint theorem, okay? I'm gonna text Mr. Check and ask him.
No, it's okay.
No, it's
No,
okay.
no,
It's
it's
okay.
okay.
It actually gets
Keep
Tell him keep
going.
going.
Tell him
Check
to turn it up.
teaches
Yeah,
class.
tell him to turn it up a little bit louder.
Take notes. Take notes.
Do more bubbles.
He's playing Warface right now.
Do more bubbles.
Okay, now, now if we look, do we have that these three sides are congruent to those three sides?
Sure.
We do, right?
Yep.
So we can go right to, we can bring this down. Oh, no, you guys, I lied.
Midpoint
I
theorem.
lied. I have to write this out. So,
Oh my.
GL is congruent to LK, and that is midpoint theorem. Okay? Then I can bring that one down and say that whatever the proof statement is, you can bring it down. Triangle GHL is congruent to triangle KJL by side, side, side. Okay? Everybody okay with that? Okay, so if you have a midpoint, you're gonna use midpoint theorem. So now, we're gonna learn a second way to show that two triangles are congruent. So far, we did side, side, side. Today, we're gonna do side, angle, side. Now, this is important. When you do side, angle, side, the angle has to be right in between the two sides. Okay? For there to be side, angle, side, the angle has to be right in between the two sides. If it's not side, angle, side. Just like this, that angle is right in between my two sides, so that's side, angle, side. And when we abbreviate that, we do SAS for that. Okay, so for today, we know side, 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 and side, angle, side. Here's another one, side, angle, side. The angle is right in between. So let's look at this proof. We're gonna write down one thing. This should have bars and a squiggly, so let's just add that. So we're gonna do segment AB is congruent to segment CD, and then AB is parallel to CD. So we have those two givens. Okay. Now, what we have it marked that AB and CD are congruent, so that's good. And then this means parallel, and do you get that's what they have those arrows for? Okay. Now, does anyone see something else we could do? Reflexive property, very good. So we can go, since this has one dash, for this I'm gonna use two dashes, and I'm gonna say segment AD is congruent to segment AD, and that is by reflexive property. Okay? Now, I was telling you earlier, if you're given a midpoint, it's going to be midpoint theorem. If you're given parallel lines, if we go back here, and you could even write this on your cheat sheet, you use this one if you are given parallel lines. Okay, anytime you're given parallel lines, you're gonna use alternate interior angles theorem. Yeah, for sure, on your cheat sheet, yes.
Do you know the song?
No, I don't listen to your kind of music.
What is that?
You're fine.
Oh,
It's not mean, I just don't.
Oh.
Okay, so if we look here, these two are parallel. So we look for alternate, guys, please. We look for alternate interior angles. And this is a place where kids get confused. Do you think I mark this angle and that angle? Do you think so?
No.
Yes.
Oh,
How you can tell is when you mark that, it has to touch the parallel side. When you mark this, it has to touch the parallel side. That's how I know I've marked the correct ones. And when I do this, do you guys get, we have to use 3 letters to name the angle?
Yeah.
Do you get that? So what letter has to go in the middle? A. So I could name this angle BAD or DAB. Okay? So I'm gonna go angle BAD is congruent to angle, and then this one D would have to be in the middle, and I could either say ADC or CDA. Either way. And now this one is alternate interior angles theorem, and here's how I abbreviate it. I do alt, int, angles, and for theorem, I do THM. You do have to write theorem there. Okay, so you have to do the theorem. All right, now, do you think I have enough? You're gonna look at one triangle. This is a side, right? This is an angle and that's a side. Is that side angle side? Yes. So what I'm gonna do is I'm gonna bring this down to step 4, and it's triangle ACD is congruent to triangle DBA. And that is side, angle, side. Everybody okay with that? Okay. Let's go to this page. So I'm gonna write down my given. V is the midpoint, and I use MIDPT to abbreviate midpoint of YZ. And V is the midpoint of WX. And that is given. Okay? Now, when they tell you the midpoint, you can't write anything until you do an extra step. What step do we have to do? Midpoint theorem. And they're telling us here that V is the midpoint of YZ. Do you guys get that means those two pieces are equal? And at the same time, we could deal with this one. It says V is the midpoint of WX. So we can also say those two pieces are equal. Use 1 dash for one of the sets and 2 dashes for the other set. So now I can write that down. I write segment YV is congruent to segment VZ, and then segment WV is congruent to segment VX. And that is what? What did you say? Midpoint theorem. And here's how I abbreviate that. MIDPT and then THM for theorem. Okay? Now, does anyone see something else there that you could mark? I haven't really talked too much, but yeah. Vertical angles, very good. So I know that these two are vertical angles, and we have this step back here. So you always want to have this out. So if you're given vertical angles, you tell that those two are congruent by vertical angles theorem. So if we go back to where we are, whoops, we're right here. I have to use 3 letters to name that angle. Do you guys get that? So I could say angle YVW is congruent to angle either XVZ or ZBX, wouldn't matter. So I'm gonna go XVZ. And that is vertical angles theorem. So here's how I abbreviate it. I do VERT for vertical. I do my angles and then THM for theorem. Okay. Now, do we have enough to say these are congruent? Do you guys all get this is a side, that's an angle, that's a side? Everybody understand that? So it's side, angle, side, and I'm gonna bring this down for step 4. So I'm gonna go triangle XVZ is congruent to triangle WVY by side, angle, side. Okay? Do you guys get for today? If you are doing that last step, you have a 50-50 chance on that, because this last step is always gonna be side, 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 or side, angle, side. Okay, so let's go, is this your next one?
Yeah.
Okay. So now we have segments bisecting each other, okay? So let's write that down first. So I'm gonna say DE and BC, and use BIS if you want to for bisect each other. And that is given. Okay, now DE and BC bisect each other. What does that mean? The bisect one, just so you know, is down here. So this would be any time you have a segment bisecting another segment. This one would be definition of segment bisector, and you show that it cuts the segment in half. So back here where we are, this time they bisect each other. So that means they both are cut in half. So these two pieces would be congruent, and you want to mark that on your diagram, and then use a different number of dashes for that and mark that those are congruent. Okay, so I'm going to go and do that step. So step 2, I could say BG is congruent to GC, and then, oh, sorry.
What was it? Deep over?
Is this where I'm at? Right here. Okay, so now I can also say DG bisects GE. DG is congruent then to GE. So those two are also congruent. And that is definition of segment bisector. So whenever you have a segment bisecting another segment, you're going to use definition of segment bisector. Now, does anyone see something else we can mark? Yes. Vertical angles, very good. These two are vertical. That's another super common step. And we have to use 3 letters. So we could say angle DGB. Angle DGB is congruent to angle EGC. EGC. Okay? Those are vertical angles, and what we write is vert angles theorem. Vertical angles theorem. Now, do we have enough written down? We do, right? So now I can bring this down for step 4. and do triangle DGB is congruent to triangle EGC, and that is by side, angle, side. Very good. Okay. One more. Okay. The last thing that we haven't talked about is we also can have where a segment bisects an angle. Okay, so let's write down our given first. So we have FG is congruent to GH. And if I look there, that's marked. Okay, then I have to write down my JG, and bisects as BIS, and this time it bisects an angle. So this is going to be a different step than we've done yet. Okay, so I'm going to go back and show you on your cheat sheet where you'd find this. And this one is definition of angle bisector. So there's going to be times where they tell you a segment bisects an angle. To bisects means cut in half. So that means these two pieces are equal in that angle. So if I go back to where we are, do you guys get if JG bisects this angle, that this would be congruent to that? You guys get that? And we have to use 3 letters again. So we're gonna come down and we're gonna say angle FGJ, angle FGJ is congruent to angle, and the other one's gonna be HGJ. HGJ, and that is the angle bisector, and the reason is definition of angle bisector. So we have a definition of angle bisector, and we have a definition of segment bisector. Okay? Now, everybody okay with that? Do you guys see something else here that's congruent? This side, right? You guys see that? They both share that side. So wouldn't we say JG or GJ is congruent to JG or GJ, however I write that? So I'm gonna say JG is congruent to JG. What is that called? Reflexive, very good. Okay, now we are at the point where we can say our triangles are congruent by what? Side, angle, side. This is a side, angle, side. So I can bring that down, and it would be triangle FGJ is congruent to triangle HGJ, and that is by side, angle, side. Everybody understand? Was that hard?
No.
So there's one where you have to do that, and then there's 4 proofs. So you should get done in class, I think.
Matthew is back there.
Yeah, I swear back here. Whatever I'll do.
You want to stay here?
I wish you would.
What?
Yeah, I don't
Whoever-
know.
whoever I do.
Well, no, I think that was Jax.
You don't?
I don't think it's Jax.
I don't think Chuck is back here.
Did you guys in the back get worksheets?
No.
Can you wait to move until you get them? That would be great.
Oh, I got mine right here. I'll set mine on my desk.
Don, can I go back?
I can work on it.
How many of you need it?